Hey YouTube, today we'll be solving climbing stairs problem from Leetcode. Let's go through problem statement. You are climbing a staircase. It takes n steps to reach the top. Each time you can either climb one or two steps. How many distinct ways can you climb to the top? Okay, so uh, let's also check constraints. So n can be from 1 to 45. So we don't need to worry about n equal to 0 cases. So let's create some base case. Let's test out all the cases, then we can decide like what are the base cases and for which cases we need to add computation. So for n equal to 1, there is only one way. You can take one step, so answer will be 1. For n equal to 2, either you can take one step and then one step, like this one step plus one step, and either you can take two steps. So there will be like one step plus one step, or you can take two steps. Okay, and for this one also write this step, so we can take one step only. And for n equal to 3, we can take one step plus one step, or we can take one step plus there we need to add two steps, and we can take two steps plus one step, and 3 will be like one step plus two steps. I think these are all the possible cases. And let's also check like, and it is 4, one step plus one step plus one step, and then there will be like 4 steps plus one step plus two steps, two step plus one step plus one step, and third will be one step plus two steps plus one step, and fourth will be one step plus one step plus two steps, and the fifth will be two steps plus two steps. So for this one, answer will be 1. Like for one, answer will be 1. So let's take that and bottom. Answer will be 1 for this one. Total number is answer 2, and for this one, answer 3. For this one, answer will be 5. Okay, so now what we can do, we can look for the pattern. So for n is 1, it's like base case, and for this one, these two we can consider base cases. And then afterwards, if you see what I'm doing here, from the previous one I'm adding one step. So for n is 2, there are two possibilities, one step plus one step. But from n is 2, if like I take one more step for both cases, so there are two possible ways they will be added over here. We can just take one step from here, and from the last case we can take two steps. So Number of ways is like answer for 3 is answer for 1, and plus answer for 2. Same here. If you let me put them. So for n equal to 4, what I'm doing, I'm taking like all the 3, then I'm adding one step. So all the values from n is 3, and then what I'm doing, like for n is 2, we are taking all 3 steps, all 2 step, all the step count, and plus 2 steps. So the answer will be like answer for 2 and answer for 3. So answer for 4, 2, and answer for 3. If we want to create a function for this one, then our function n, like a function that takes n as input for n is 1, n equal to 1, or we can write it this way, n less or equal to 2. Our function answer will be n. Answer will be n, and if okay, let me write this way. We are trying to write a function, so if n is less than or equal to 2, answer will be n, because for n is 1, answer is 1, and for n is 2, answer is 1. Answer will be n, so fn will be n, and for other cases fn will be for sum of all values for n minus 1, and sum of all values in minus 2. So it looks like a Fibonacci problem, so we can solve this using dynamic programming now. Okay, so let's write the code. Let's create one DP array. Add the base cases for the DP. Okay, equal to 3. Okay, so I minus 1, and since all the calculations are complete, we can return DP. So as of now, I'm using like a standard approach of the DP, like creating one DP array and then populating all the values. There is also one more approach similar to like Fibonacci number. We can use only previous 2 values. If you want to look at the solution, you can go to my Fibonacci numbers video. So that is a bit more efficient. Here we are using order of and space complexity, but as of now, I'm going only with like standard approach. So let's run the code. Okay, I was meant to declare a vector. Okay, and now it looks good. Let's submit it. Okay, so this is faster than 8.82 or C++ solutions, and we are using memory 6.2 MB. Let's analyze space and time complexity for this one also. So we are using one loop. Let's analyze space complexity for this one. Complexity. Complexity. Since we are using one loop, so time complexity will be order of n. Space complexity. Since we are initializing one monoarray DP array with n plus 1 size, so space complexity will also be order of n. If we want to optimize the solution, we can take that similar Fibonacci number problem solution. This way, time space complexity will be order 1 because we will be using only 2 variables. But as of now, I'll be going with the standard approach. That would be it for this video. Thanks for watching. If you like the video, you can like the video, and you can subscribe the channel. Thank you. Bye.